Hello students, welcome back to my YouTube channel Data Shah. In the last video I was talking about partial differential equations numerical solutions. So today I'll be continuing further, in which in today's class I'll be talking about the classification of the PDE when we have certain conditions. Okay, so first of all I have explained what is partial differential equation and what is the difference between the PDE and the ODE in the last lecture. So you can refer to that lecture. So there are various applications of the PDE. So I hope everybody knows that in physics we have like fluid mechanics, solid mechanics, heat transfer. The PDE, the solutions of the PDE are required. Similarly, when we are talking about the various branches of applied mathematics like fluid dynamics, boundary layer flow, elasticity, here also we require the solutions of the partial differential equations. So these equations satisfy some specific conditions which are known as the boundary conditions, and that's why the PDE together with the boundary conditions is known as a boundary value problem. Now, coming back to the classification, I have already explained that we can write the second order PDE in the form of, so I'll write this, I can write it as I can rewrite it as A del square u by del x square, B del square u upon del x del y, C del square u upon del y square, where I have explained you that all the constants A, B, C, D, E, F, G are the functions of x and y. So now what is the condition we have for the classification? So we'll be considering the discriminant, that is b square minus 4ac. So if the first case, if your discriminant is less than 0, then your equation 1 is said to be elliptic. If the discriminant is equal to 0, then the equation 1 is said to be parabolic. If the discriminant is greater than 0, then the equation 1 is said to be hyperbolic. So these are a few conditions, and I have explained these in the last lecture as well. So continuing further, I'll be taking questions related to this. So let me take first question. You just need to classify the equations. Classify the equations as hyperbolic, parabolic, and elliptic. So let me take the first part. So here you will notice that instead of del square u by del x square, this is written as uxx. This is nothing. I can rewrite this in that form only. This is del square u upon del x square, del square u upon del x del y. del square u upon del y square. So this is just another notation to represent it. So here what we need to consider, what are our ABC? So A is x plus 1, B is minus 2 times x plus 2, and C is x plus 3. Now the discriminant, so B square, then 4 times AC. So you just need to open the brackets, and when we'll solve it, let's see what we'll get. 4 times x plus 2 whole square. And let me just solve this. So this would be 4 times so when I'll open the brackets, I'll get so as we could see here, the terms will cancel out. So the final answer that we are getting is 16 minus 12, that is 4, which is greater than 0. So now using the previous, on the previous page that I have written the classifications, because it is greater than 0, then I can say that this equation is hyperbolic. So thus the equation is hyperbolic. So it's very simple. You just need to calculate and write the answer. So let me take another question. Now in this, you are also having the other values, right? So I can again rewrite this as I square del square u upon del x square del square u upon del x del y. So here again you just need to consider ABC. So A is y square, B is minus 2xy, and C is x square. So the other values that we have, that is this and these. This represents your F, if sorry, this is D, right? The coefficient is D, and the E coefficient is missing. That was for del U by del Y, and this is F, right? So I'll just show you. Here you could see the D, E, and F. These are also the functions of x and y, but we don't need them when we are finding out this discriminant value. So to find the discriminant value, we don't need it, right? So, so here I'll be just taking this, considering only ABC. So I'll calculate that's minus 2xy whole square, 4 times y square, x square. So this is 4x square y square. That's same as we know, so it is coming out to be 0. So as the discriminant value is equal to 0, so therefore the equation is parabolic. So such kind of questions are easy to understand, but if there is a certain other conditions given, then how would we do that? For example, you have the equation as this. and you are given the condition on the x and y's. So this is your second order PDE, and it has only, let me just write, a is given to you as x square, b is not given, that is 0, the coefficient of del square u upon del x del y, and c is again 1 minus y square. Okay. Now, what is given to us here? Apart from this, we are given here the range of x and y. So that means x can take any value on the number line from minus infinity to infinity, but y should take only the values from minus 1 to 1. So here, if I draw the lines, you will notice here, so if you could see here, notice here, this is y is equal to 1, this is y is equal to minus 1, and x is ranging from minus infinity to infinity. So, right, so this is my x-axis, this is my y-axis. Now we need to find out within this range what my equation is coming out to be, whether it is coming out to be elliptic, parabolic, or hyperbolic. So I need to consider the values also here. So I'll be taking this range in mind. So this is very important to keep in mind. So I'll just square it. Now, my discriminant, that is b square minus 4ac, as b is equal to 0. So this would be, so I am getting here minus 4x square, 1 minus y square. So that's a minus 4x square plus 4x square y square, or I can write this in this form as well. Now, when we are talking about this condition, what you need to keep in mind is that here x square is positive, right? If you consider this, I can also, let me just write it in this form. So 4x square, y square minus 1. Okay, so this would be easier for you to understand. Now, as we know that the x is ranging from minus infinity to infinity, and we have x square, so it won't matter here because x can be negative, x can be positive, but because it is a square, so this term would always be greater than 0. So as x lies between minus infinity to infinity, x square is always positive. Whereas when we are talking about y, because it is lying between minus 1 to 1, as y lies between minus 1 to 1, y square minus 1. Now, what do we need? It would be y square minus 1 would be greater than 0 or less than 0. Because this term only will depict whether this equation is elliptic or hyperbolic. It cannot be, the discriminant cannot be equal to 0 in this case. It can either be hyperbolic or it can be elliptic. So in what would be the conditions? So let me take the another page so that I can explain it well. So there are only three cases as we know. So either delta would be equal to 0, greater than 0, or less than 0. Now in this case, when we are talking about that it is equal to 0, is this possible? No, that's not possible because here we are getting del as 4x square y square minus 1, right? So it would be equal to 0 when we would say that y is equal to 1, right? or x would be equal to 0. So it is possible only if x is equal to 0, because y cannot be equal to 1 or minus 1, because where we are talking about the range, it is strict inequality, right? So we can't take y to be equal to 1 or minus 1. So it is possible only if x is equal to 0. So we'll be getting discriminant equal to 0. Now, when we are talking about this discriminant greater than 0, so it is possible only first point if x square is always greater than 0. So y square minus 1 is greater than 0, right? That means y square is greater than 1. So can y square be greater than 1? If you'll see the range, is this possible? So it is possible only if this condition holds, but this is not true. Why this is not true? Because y has to lie between minus 1 to 1. It cannot be greater than 1. It cannot be greater than minus 1 either, right? Less than minus 1 either. So it has to fall in this range only. And y square greater than 1 means the value of y has to be 2, minus 2, or minus 1.5, minus 3, minus 100. But that's not possible at all. So this case is not possible. So this is not true because y has to lie between minus 1 and 1. Now the only that is left is discriminant less than 0. So in this case, this is possible only if your y square minus 1 is less than 0. That means y square has to be less than 1. Yeah, this is possible. Y square can be less than 1 because if we take y to be in this range, so this is possible. So thus we could say that the equation so less than 0 means it has to be elliptic. So equation is elliptic if the given condition would be that y square is less than 1, or it is parabolic if x is equal to 0. So you have these two conditions with you where you will be talking about either it would be elliptic or it is parabolic. So this is what we have in this question. So this is very important. Now I'll take another question in which we are given a condition. So let me take another question. In which parts of the xy plane is the following equation elliptic? So the equation that is given to us is so this is the equation that we have. Now, as you could see here, what we need to consider only the ABC. So this part is irrelevant. You can take it on the left side and that would become your F. remember, or sorry, this is your g, just a constant. So this is constant value, right? So that again is a function of g. Now here we need to consider only a, b, c. So a is 1, b is also 1, and c is x square plus 4y square. So our discriminant value, that is b square minus 4ac, is this. So I'm getting this as 1 minus 4x square minus 16y square. Now, in this question, they are asking us in which parts of the xy plane is the following equation elliptic. So we need to find out those parts. That means that particular condition in which this equation is elliptic. So the equation would be elliptic when your discriminant value would be less than 0. So the equation will be elliptic if the discriminant value is less than 0. That is 1 minus 4x square minus 16y square is less than 0. Now, let us see the condition that we are getting here. So, I'll take this on to the right hand side. So, I'll be getting here 4x square plus 16y square is greater than 1. So, I can rewrite this equation. So, let me go to the another page. So, I had 4x square plus 16y square greater than 1. So this is same as, let me just, so that's equivalent, right? X square upon 1 upon 4, y square upon 1 upon 16, right? So that's greater than 1. So can you figure out what is this equation similar to? This is the equation of the ellipse. So equation of the ellipse is given by x square upon a square, y square upon b square equal to 1, right? So now you would say it is coming out to be greater than 1. So wait for a second, I'll explain that as well. So let me just square it. Now I give what is 1 upon 4? 1 upon 4 is x square upon, if you'll calculate, it will come out to be 0.25. And 1 upon 16 will come out to be 0.0625. Now, if I have to write it in this form, then what would be the a? Because this is the square, 0.25 is the square. So it would be x upon 0.5 whole square, right? And this would be y upon 0.25 whole square, greater than 1. Now, this is my condition. Now, what is the condition? Condition states that we know that this is our equation of the ellipse. But here in the equation of the ellipse, what you could see, we are having greater than 1. Now, what is it saying? The equation will be elliptic if this holds. Now, which x and y we are talking about? So, the x and y which are lying outside the ellipse, because this is greater than 1, right? Equal to 1 means that you are on the boundary of the ellipse. Okay, if you would be getting equal to 1, that means you would be having on the boundary of the ellipse. So if I have the ellipse like this, right? This is my ellipse, okay? And these are my lines. So for example, it is coming out to be like this. This is a random figure, please. So if I have x square plus a square, x square upon a square, y square upon b square equal to 1. So that means it is lying here on the boundary, right? If I am having that x square upon a square plus y square upon b square is less than 1, that means it is lying in the inner region. And if I would be getting the equation as x square upon a square plus y square upon b square greater than 1, that I'm talking about this region. So all those xy's which are lying outside the ellipse, right? This particular ellipse. So these are specific conditions. The same holds the same for the circle if you'll be getting an equation of a circle in the answer or anything that you are getting. So this holds the same for everything. So now I can say thus the equation will be elliptic for those points in the xy plane where I could say that where I would say that this is lying outside the ellipse. For those points in the, thus the equation will be elliptic for those points in the xy plane which lie outside the ellipse. So which ellipse? This ellipse only. So you can also write it in this form. So x square upon a square like this. So this is the final answer. So we got a condition, and I hope this would be clear enough. So all those xy's which are lying outside to this particular ellipse, on that particular points, your equation will be elliptic. And if it would ask that if when it would be equal to 0 or it would be, I mean, hyperbolic, right? You need to find out here hyperbolic, then it would become a different question. And when we are talking about the hyperbolic, so I'll take that as well. If um, sorry, the equation is hyperbolic if your discriminant is greater than 0. So that means your 1 minus 4x square minus 16y square is greater than 0. So you will notice that you are getting here this, right? So when you'll solve this, ultimately you are getting this less than 1, right? So this is x upon 0.5 whole square plus y upon 0.25 whole square. Now, the equation is hyperbolic. The equation will be hyperbolic for those points in the xy plane which lie inside the ellipse. So this is how you can formulate write the answer. So if it would be hyperbolic, we are talking about the inner part of the ellipse. If it would be parabolic, equal to 0 would be when you would have the points on the ellipse only. So if the equation we are talking about would be parabolic, so the equation will be parabolic if your discriminant is 0. So that is 1 minus 4x square minus 16y square is equal to 0. So this is equivalent of saying x upon 0.5 whole square y upon 0.25 whole square is equal to 1. So that means now we are talking about only those points which are on the ellipse. So thus the equation will be parabolic for those points in the xy plane which lie on the ellipse. So one question I have explained all the three parts to you. When it would be parabolic, when it would be hyperbolic, when it will lie inside the ellipse. Parabolic, it would be when it lie on the ellipse. And the previous one, that was, it would be elliptic when it will lie outside the ellipse. So I hope this would be clear enough to you. So such kind of questions are important for the classification of the PDE.